Alright, so partial fractions again, part 2. This time we're going to use the other transformation. Now, we're finding the integral of 4x plus 5 over x plus 2 squared. Now, it's tempting to take x plus 2 and break it up into x plus 2 and x plus 2. If you do that, the tops of your fractions are going to get all messed up. You're not going to be able to find two tops. So instead, you want to break it up. So it's going to be 4x plus 5 over x plus 2 squared. And we're going to let that equal a over x plus 2 squared plus x plus 2 over b. Alright, and then think about how we're gonna add those two partial fractions together. That a is going to stay as it is, so it's just going to be a over x plus 2 squared. Sorry about squeaky pen. And the b is going to be b bracket x plus 2 over x plus 2 squared. And obviously then we can scoop that all together and it'll look like this. A plus b bracket x plus 2 over x plus 2 squared. Now that we've got something that looks like that, we can equate our numerators. So we do a little therefore. 4x plus 5 equals a plus b x plus 2. And then we can solve those things in the same way that we've done in the past. So we can let x equal negative 2. So that means that 4x plus 5 is going to equal a. Oops. And x is going to be negative 2. So 4 times negative 2 is negative 8. Plus 5 is negative 3. So a is going to be equal to negative 3. And then we just need to find our b value. Now in the last question, to find the b value, all you did was sub in another value for x. Like we let x equal negative 2 and you let x equal something else. It's not really going to work this time around, but because we're using this special case x plus 2 squared or something squared on the bottom, we can simply sub in what our a value was. So sub a equals negative. So when I sub that in, I'm going to get, let's make a little box here for me to do it in here. I'm going to get 4x plus 5 equals negative 3 plus bx plus 2b. Now, take a look at that. You've got negative 3, which is a number. You've got 2b, which is also a number. And then you've got bx and 4x. So there's two ways to solve from here. You can equate the variable, so you can say, we can do like a therefore. Therefore 4x equals bx. So bx equals, so therefore b equals 4. So there's one way to do it. You could have also said that therefore 5 equals negative 3 plus 2b. 8 equals 2b, and b equals 4. So we can find b in two different ways. Anyway, and that happens in this instance with the squared denominator. Now that we've done all of that hard work, we can rewrite it as a partial fraction. So we can say that we're finding the integral of x plus 2 squared plus x plus 2. And we can say that the a value is negative 3 and the b value was positive 4. And then all of this is going to be plus, not plus c yet, we haven't integrated it yet, with respect to x. Now we just need to integrate that. Now when you integrate that, that's going to be a log. That negative 3 is going to come out of the outside. Now when you're integrating this, be a little bit careful. Negative 3 on x plus 2 squared, that's not going to be a log. You can integrate that as just as a polynomial by taking x plus 2 to the top and making it x plus 2 to the negative 2 and then integrating that. Now, when you do that, you're going to end up with the integral being 3 on x plus 2. So pretty straightforward there. Now the integral of this one is going to be a log. It's going to be 4 log base e x plus 2. And now all of that's going to be plus c. And obviously x needs to be greater than negative 2. Because we can't have a 0 in there. So there's another little integration using partial fractions. The only difference here was the x plus 2 squared on the bottom of our fraction.